Welcome to our next tutorial of QuickSurface. This tutorial we will learn about the freeform modeling and all the details, tips and tricks and how to use it. The freeform modeling is designed to make reverse engineering of the parts, which is hardly can be modeled with other surfaces, and this is a small example of this one. Although it looks simple, it's quite difficult to build with extruded or revolved surface, so this is clearly a freeform, and this is how we can address by using our freeform tool. In order to start a freeform, you can just hit the button on the main toolbar. When you enter the mode, you have different commands on the action toolbar, and then there are many options here which we can go through now. At the start, I'll just put the model in top view just to highlight that this is a symmetrical object here, it's properly aligned, and we can start our modeling. By default, the option is set to add face mode, and this happens just by clicking on the screen and creating 4 points in space wherever you want to place them. You can always have undo. Also, the other option is if you want to make a perfect rectangle, then you can choose the second command, which is called rectangular face, and then all you need to do is just click on the 2 points on the 2 corners. And now, as you see, we created our first quad. So what can I do now is that I can manipulate this and start modeling. First option is when you use the mouse hover, it highlights the elements. The elements of quad surface are points, edges and faces. So the options are that the user can put to points mount only, and then you cannot select anything else. Edges, only the edges are selectable. You can put the faces only, then it highlights the faces and you can select them by clicking on them. Or you can make extensive selection, so you can select whatever you want. I personally find that points and edges is quite useful and enough for the purposes of modeling. So then we have this trunk length, which I'll go later, but now we created this, and what can we do now? It's that we can select an element, and then you can see the manipulator. The manipulator, which is called in some software gumball, is drawn on the screen. It shows you different direction which you can move the object. When I say object, I mean either a face or point or several points, and you can move using the arrow, which will move in the X direction, Y or Z direction, or if you hold these small white squares, the element will actually move in the plane, in this case XY plane. In such a way you can modify it and move the elements in space. You can choose how this manipulator is oriented. By default it's aligned to the world coordinate system, but you can put it into screen coordinate system, so it doesn't really matter how you move the object, you always see the XY of the screen. And then there is a third option, which is local, which I will show you a bit later. So once we have this small rectangle, we can start actually build our surface. If I highlight an edge, you can see a small D sign here, which means that if I hold my left mouse button, it will duplicate my edge. So in such a way we just increase another edge here and we extended this surface. Then I can take this point and I can move it down and I can build this. For example, if I duplicate here, I'll just undo this because we're not ready yet from the top view. So now I can double click. If I double click, it just selects the whole chain of edges. So this is really flexible, and then you can just duplicate the edge out. I can double click here and I can move this inside. So the next step would be, let's just put the manipulator in the world corner system, show you a bit more here. If you have more elements selected, you can see these quad circles. This means that you can actually rotate the selection around their extents in this plane, or you can scale the selected like this one. For example, if I select these 6 points, actually the way we can select those is just by holding the left mouse button, dragging and lifting. This will select all of them. So now, as you see, I can scale and I can change my shape. Another way of duplicating an edge is, if you double click, you select everything, you just hold the Alt key, and instead of using the D sign, you just precisely, if you hold Alt key while holding it and then you move, it will duplicate the edge. This is useful if you want to make really exact extracting of the points here. So this is how we started now to build our first couple of rectangles here. You can just manipulate and you can see the shape, you can change it. I can just take, if I use everything, I can just move the whole face up and down, move it in space, and in such a way create my freeform surface. The other thing is about this type of modeling is that this is the result surface, but it's controlled with what we call a control net. A control net is actually can be analog to the B-splines. This is the control net which defines the underneath surface. So if we take a look here, this is the control net and it generates freeform between them. So this is a kind of a control points for the surface, but you can always switch this off and you can use actually with the feature points. This makes the software quite easy to use and you can see what happens on the screen. I'll just put it on top. So if I just duplicate here with the Alt key and like this one, and if I just try to move this, because of the spline theory, you see that these neighbors, they actually move in space also. There is an option, so you can turn this option on, don't move neighbors. This means that the software will actually try to keep the point here and not to move them in space. This is useful in many cases when you want to refine the results. Now, there is an option which is called drag strength, and it's useful when you want to do some really fine tuning. I can just put these 2 points and faces and edges. I click here, and if I move this, it moves with the mouse. But in some cases, you may need to move really slowly and really fine, so you can change this drag strength. And as you see here, even if I move with the mouse, it moves really slowly. I can put it even to the minimum, and then it's actually really slow. At any point you can turn the zebra rendering, which gives you the continuity in the map, and you can have analysis of what your surface is. So when you work and when you modify your control points or feature points, you can see the smoothness of the surface. QuickSurface provides G2 continuity between the patches, and if we have extraordinary points, the continuity G1, which means the tangency. I will put this in top view and we'll continue. You can turn this on and off from this display mode. You can adjust some parameters of the zebra rendering. You can change the stripe width, you can make it vertical or horizontal rendering, and then you can change it to different colors depending on the user preferences. When you're ready, you can press done. The mesh display is also interesting option. So if we put this on the screen, there are two ways of how we can render the mesh. It can be rendered a bit slightly behind the surface, but this is only that it's rendered like this, not that the mesh is moved. So the user can see, or you can just use the slider and you can see how the rendering is. Later we will learn that this is important, and in some cases this is not enough, so that's why we offer abilities to render it as a transparent, and then the slider in this case will affect the transparency of the mesh. So you can always just use these two options to adjust the visualization of the mesh. Another option which we have is what we call the tolerance display. When we are in the tolerance display, our result surface is compared to the mesh, and you get an instant result on the screen of your deviation. You can of course set your tolerance, how close you want to be, let's say 0.5 millimeters in this case, and then when I just move in real time you can see my deviation. We'll start later to remodel this part, and you will see how powerful this option is. And the last thing in our basics in the freeform is that we support the symmetry. I will just delete this part here because I don't need it. The symmetry is working only on the main axis, so that's why you have to pre-align your object properly if you want to work with the symmetry, and you can choose which side it needs to be our symmetry plane. So when the symmetry is enabled, whatever I do in one part will actually appear on the others and keeps all the points symmetrical. Big question is what happens here, and as you see, if we try to snap them, they don't really snap at all because of the symmetry. In this case, we have options, so the user can just double click the whole edge chain, for example, which needs to be on the symmetry, and then he can set on a symmetry plane. Now what happens, the software always visualizes a green line showing us where the symmetry is. Having this symmetry, so this means that even if I try to move the point sideways, it always stays on my plane of symmetry. Then one interesting fact is that the continuity between the patches on the symmetry, because it's also G2. So in such way you can get a good and nice and smooth transition. I'll just put this at the back. So this is our first freeform surface which we managed to create in no time. And just to add that all of these options are also accessible on the context menu, and this works by right clicking, and then you can choose how the selection should be, the manipulator, and what the mesh model displays. Maybe now it's good to speak a little bit what local means. This means that if we have a freeform surface like this one, and if I define my manipulator, as you see, the Z direction of the manipulator is the normal of the surface, and this is also quite useful. There is no warranty what the X, Y will be, so this is most powerful if you want to move a point only in the direction which is perpendicular to the surface. So this was our first base tutorial how to start. We will continue in the next one with the more advanced tools and settings. Thank you.